Welcome. The title for today will be, you can see in the title, reactions for simply supported beam. In the bracket there will be vertical reactions for couples. You can write here, main, no space right here. Vertical reactions for a simply supported beam subjected to couple or couples. Okay. Now, before I start the discussion, some principles are there. Those who are serious correctly observe. See, some dictation is there. Here I cannot write everything. See, consider a beam AB. Let both ends be pinned. I want a pinned support at both ends. Now remember, usually you take, suppose you take simply supported beam, only vertical reaction. Only vertical reaction. Or suppose you consider one pinned. Pin means, actually pin you can show very easily by a round. See, one pin and other roller. This is pin. See, this is the pin. Sometimes pin they show like this also. Both are same. Then vertical reaction here, vertical reaction here, horizontal reaction here. But we are not considering horizontal reaction. Remove it. Oh, once again, see here because of ink flow, 1 minute here. Here I told both ends are simply supported. Both are simply supported. Okay. Vertical reaction. So here also vertical reaction, here also vertical reaction. Or if you consider both pinned, then once again, vertical reaction, there can be horizontal reaction here. But right now, we are not concerned about horizontal reaction. Therefore, remove it. Again, vertical reaction. I will tell you why I am using pin. There's a reason. Later, I will once again go back to simply supported beam. So, pinned, see here. Two supports are here. Two supports are here, a pinned support. Now, right here, let the beam be subjected to couple. See, couple means, see, I'll show you, you know, couple. Not one couple, any number of couples. See, random. Maybe some clockwise, some anti-clockwise, random couples. This is the arrangement of the beam. Two beams are there. See, I will do one thing now. This I will call beam 1. For understanding correctly, this I will call beam 1. Beam 1. This I will call beam 2. Beam 2. Okay. Later, principles are there. Now see. Now, there are so many couples are there. Actually, it can be one couple. Now, what happens is, if a multiple number of couples are there, for reaction calculation, you can replace by a single couple. How single couple, I will tell you later. When I do the example, I will tell. See, by algebraically adding all the couples, you see the net clockwise, net anti-clockwise, then find the difference, whichever higher is the net couple. Net couple. See, suppose today you earned something, you got some money. Tomorrow you spend some money. Day after tomorrow some more money will come to you. Next day you spend some money. You know how to calculate net. The net can be what? Either profit for you or loss. Maybe who knows? Your income is more than expenditure. You are on what? Profit side. Or your income is less than expenditure. You are on negative side or loss side. Some loss. Maybe you have taken some loan. So now make a note here. Multiple couples. Now, again you write here, let. You should write M. It's a flow of ink. I think I put excess ink. That's why it's happening. Okay. Become a little dirty. Okay. Now, some statement you have to write. See, common for both. Let M be the resultant couple or net couple or single couple which is resultant for all the external couples. See, these are all external couples. Be careful, right here. External couples. That is action. These couples are all action. Let M be the net couple or resultant couple. I will use the word net couple. Net effect. M. Now, two chances are there. The net couple may be clockwise or anti-clockwise. So, therefore, right here, for beam 1, let net couple M be clockwise. You should write here. See, I am dictating. For beam 1, let that net couple be M clockwise. For beam 2, let that net couple be anti-clockwise. Show wherever you want, because why? Distance does not matter when you find reaction, because couple into no distance. Okay, over. So for beam 1, all this action replaced by a single clockwise couple. For beam 2, replaced by a single anti-clockwise couple. This all the statement I am dictating, you are right. But remember, in the notes, this I will write for 3-4 pages. Okay, now, support reactions required. There will be reactions here. See, even if there is no loading, reaction will come. See, correctly observe here. I will tell you something now. You take a beam, see, beam. If you hold the beam here, if somebody rotates, either clockwise, anti-clockwise, see, reaction will come. See, it will try to move the supports. So there will be reaction. So let VA and VB be vertical reactions for both the beams. Let VA and VB be vertical reactions for both the beams. Okay, now, what about direction? Correctly observe how the reaction will come. Now, see, what I will tell is, this couple M is clockwise. You should write, consider beam 1. This couple M is clockwise. See here. If the couple M is clockwise, see what happens. See, you hold here. If you apply a clockwise couple, it will try to lift the end A upward. It will try to pull it up. But it's a pinned support. It cannot move. Suppose someone will push you this way, you push back. So when you see this couple, when you apply clockwise couple, see, clockwise couple, support A, it will lift the support up. So support will give a downward reaction. Later I'll give simple example for you, whereas this couple will push the support B down. See, this couple, clockwise couple, will push it down. So there will be vertically upward reaction. So the reactions are opposite directions, but they are equal in magnitude. I will tell you later. Here, see what happens. If you apply, see, if you hold here, if you apply anti-clockwise couple, support B, it will try to lift. But support cannot get lifted. It will prevent it. See, this is a reaction. Reaction is opposite to action. Action is to lift. So support B will give reaction like this. And this couple will push the support A down. So this will give upward reaction. If any confusion is there, later I will explain once again briefly. Okay, therefore, I am assuming this is downward, this upward, here it is upward, it is downward. Now, for equilibrium, sigma V0, resultant vertical force should be 0. Now, no plus minus now. Therefore, whatever is the downward VA should be equal to the upward VB. So, VA should be equal to VB here also. For that, when there is no loading is there, they should balance each other. So, this upward VA will be equal to downward VB. So, both the cases, see, sigma V0 for both the cases, no plus minus because we already showing correct direction. VA should be equal to VB. Now, VA and VB are, now see, I told VA equal to VB. So, when the VA and equal to VB, like, see here, suppose this beam, VA is down 10, VB is up 10. Now you know it. Or here, VA is up 10, VB is down 10, something like that. Then VA and VB are two equal unlike parallel forces. Now go back to engineering mechanics. Two equal unlike parallel forces, there is no resultant force it will form a couple. The moment of that couple is product of any one of the force and perpendicular distance between the two forces. So they will form a couple of magnitude either VA into L or VB into L. VA into L, or remember, it is not VA into L plus VB into L. See, if this is 10, if this is 4, moment of this couple is any one of the forces, 10 into 4, not 10 into 4 plus 10 into 4. Moment of a couple is product of any one of the force because they are equal forces. Then, and perpendicular distance between them, so they will form a couple of magnitude VA into L or VB into L. Now, right here, which will be anti-clockwise for beam 1 and clockwise for beam 2. Reason, I tell reason here. Reason. Correctly write what I tell now. See. Beam 1, your action is clockwise M. External effect is clockwise M. To balance that clockwise M, you require anti-clockwise couple. See now, VA down, VB up. This will form anti-clockwise couple. For equilibrium, action and reaction should be equal and opposite. So, this couple developed by the reactions will be equal to the external couple M. Now, again for equilibrium, sigma M0, the couple formed due to VA and VB should be equal in magnitude but opposite in direction to the net couple M on the beam. Class, write everything I tell now. Now I am writing one thing now. Class, what all I tell you write. Therefore, see, but that already I told here just now. Or you can write here, one more note here. The M, couple M is external or action. The couple formed by reaction is resisting one or it is a somewhat internal type. See, if you apply a couple clockwise here, you write once again there, a clockwise couple will try to lift A upwards and push B downwards. So, therefore, when you try to lift upward, reaction will come down. When you push it down, reaction comes up. Here, the anti-clockwise couple will push A down. Actually, the class, what I will do is, I will take a scale, give to two people, and then apply the couple. See, this way. Then I will tell them, first I will apply, it will move. I will tell, don't move. Then this person will pull it down, and this person will push it up. You can try yourself only. You hold this way in the finger, ask someone to turn here. But don't allow the scale to fall down. Let it be there only. Surely, in this finger, when a couple comes here, you will push it down, you will lift it up. Here, opposite. That all right here, everything what I tell. Therefore, your VA into L or VB into L will be equal to M, or your VA magnitude value equal to VB, directions are opposite, equal to M by L, or vertical reactions at both ends are equal in magnitude but opposite in direction, equal to net external couple on the beam divided by span or distance between the supports. Okay, now I'll give final summary here, and then I will tell you those people who find difficulty for all these, you do one thing. I will tell them, okay, assume both reaction upward. When you calculate, one of them will come negative. One of them will come negative. Negative sign indicates that assumed direction is wrong. So then you have to put opposite direction. So I will solve both the ways in the class. So all this principle you remember, and you finally, a summary, I'll give next round now. I'll give summary in the next round. Full board, I'll give summary with some precautions. Now remember, I will give summary, final summary. Very, very important. What all I tell, you should make a note and go through. I wrote somewhere here. If difficulty is there, go through 100 times. All, everything. Because later I will not explain. I will tell class number so and so. Okay, start. What principle we are telling? That is reactions normal to a member. If the beam is horizontal, vertical reaction. In case of frames later in structural analysis, if member is vertical, horizontal reaction. So anyway, this you worry later, not now. I made a note. We are discussing about reactions normal to member when for only couples, nothing else. But any number of couples, no problem, but only couples. Also, no other load, point load, UDL, UVL, nothing. Only couple, also supported at both ends. Both ends should be supported. And what type of support also important? Where both ends should be supported, where reactions normal to beam is possible. You should have support where there will be reaction normal to member. That is simply supported beam, okay. Why? Horizontal beam, vertical reaction. Or this member, okay. Even both end fixed also okay later. But not one end fixed, one end prop. That also okay. But not cantilever. Not valid for cantilever. For this separate note is there, because cantilever, suppose you apply this trick for cantilever, one support is there. Where is other support? See, two reactions are there. We are discussing reactions at both supports. So cantilever, class, warning, never foolishly apply this principle for cantilever. For that, separate principle is there. Now, any number of couples, I told. What all I told? I told, remember, member horizontal, there should be both vertical reaction. Member vertical, both sides horizontal reaction. That's all. Any number of couples, what to do is, M, let M be one case, second case. See, two cases are there. Let M be net or resultant couple. You can make a note. If single couple given, okay, M. If multiple couples are given, replace them by a single resultant couple. How means I will tell you. Actually, you know it. Simply algebraically add. Clockwise 100, anti-clockwise 80 means clockwise 20. Or clockwise 100, anti-clockwise 120 means anti-clockwise 20. Now, remember, see both the places M. This M is net or resultant external couple. External, you are right here also. That is actually action. See, it is external, it is action. Now for the action, you require reaction. We are concerned about reaction. First of all, remember, action and reactions are equal in magnitude but opposite in direction. Therefore, now start. You take both pin. I already told you, both pin means both simples of, we want only vertical reactions. Horizontal, we are not bothered. I already told earlier. Okay, now, couple M, this span is L. Here also, couple M, instead of span, see, here, what you call span, that is called height. What you call span is called height. Okay, leave it. Not required now, further. Now, first I will tell you, correct, easy or concept actually. See, if there is an action of M, imagine clockwise. To balance it, you require an anti-clockwise couple. That anti-clockwise couple will be developed by the reactions. So, the two support should develop reactions so that those two reactions should form a couple which should balance this couple M. If the couple is M, The reactions are, see, these two reactions will create anti-clockwise couple. So that's why I put this way. See here, if the couple is anti-clockwise, these two reactions will create or produce clockwise couple. And the moment of the magnitude of the couple that is due to reaction equal to any one of the reaction into L. Therefore, any one of the reaction into L equal to M. So, any one of both the reactions are equal to M by L. Down M by L, up M by L, up M by L, down M by L. See here, apply this way, this will produce, if you apply clockwise, anti-clockwise. If you apply anti-clockwise, clockwise. This is correct concept. Then, for those who find difficulty for all these things, what you do is, you take your pen, place on the two fingers. Remember, reaction should prevent the displacement. Remember, this I told 1,000 times. When the action tries to displace, reaction should try to prevent it. See now, if I apply a clockwise couple, this side gets lifted. See, that is lifted because of action. So reaction should prevent it. It should bring it down. See, down. That side, it will try to push. So reaction is up. Here, if you apply anti-clockwise couple, see that side, it will get lifted. So you require reaction down. Here, it will press here up. Or I will take a pen, give to a student, and I will apply a couple here. Then I will ask what you are doing. Sir, I am pulling it down, I am lifting it up, they will tell. Here, they will tell, sir, if I apply this way, sir, I am pushing up, and here, pulling it down. Some word they will tell. This is little better. Or for those who have difficulty, easy method is there, write it 100 times. Nothing required. First of all, before you write that note, make it. Both reactions are equal in magnitude, but opposite in direction. Big letters. Therefore, if one side is up, other side is down. If this side is down, that side is up. That you have to remember. Then, and equal to whatever is the net couple divided by span, M by L. That you remember. Now, all you do is take a pen, place here. See the first case. Apply a clockwise couple. You can very easily feel one side gets lifted. Lifting is important. See, oh, this gets lifted. If it gets lifted, don't allow it. See, when lifting comes action, reaction, you move it down. Down. Then other is up. Here, when you apply action this way, that gets lifted. To prevent it, you require a down. This is up. See here. Here, not lifting, left, right. When you apply couple M here, see, this will try to move this side. Reaction this way. Here, opposite. Here, see. If you apply anti-clockwise, it will try to move this way. Reaction that way. So remember, all these points I told, correctly go through, understand, and make a firm note. When I solve the questions, I will go for both options. First, for those who does not understand anything or any of this one, but they know how to systematically solve sigma m0, sigma v0. But trick everywhere, every time, I will apply the trick and get the answer. Trick means what? It's not a trick actually. It is actually sigma m0, sigma v0 only. Okay. Now, that problems I will take in the next class. Okay. Thank you.